Okay, so I just wanted to run through this validation case that I'm currently doing. So I'm going to start off on Runpod. I've only got a small amount of credit left, but it shouldn't take long. So I'm going to start by creating a new Runpod instance or GPU. So looking at the GPUs, I normally use this A40 because it's quite good value for money. So go down. You can use a spot instance if you want, but I just normally use the on-demand one and deploy on demand. So I'm creating this GPU instance so that I've got something to run my code on. So that's just going to take a few seconds to get started. In the meantime, I've got Power View in the background ready to go. I've got my Linux terminal here, and I've got my input file here. So I've got everything ready to upload as soon as the pod's ready to go. Right, so first thing I do once that's loaded is run Jupyter Lab. Sometimes it fails if you try and start it too soon. So I'm going to upload from Ubuntu. I'm working, this is the tedious bit. Octree, so it's my Octree solver. And I want to upload the GPU executable, the input file, and the geometry. That's all I need. So those three things, once they have uploaded, I should be able to see them. So the only thing I need to do that now before I start running is just to make it executable. So my executable file that I've just uploaded is now executable. This is my input file. That's my geometry. So I'm going to run it. And I normally like to use the time command. Oh, that's good. You need to specify the directory. So that starts off by reading the STL, creating the octree mesh. So I've run this case many times now, so I know that the octree mesh is about 1 million cells. So that's literally just done that created the octree mesh. Then it takes a few seconds to calculate the neighbors, and it tells you the mesh summary just up there, and that's running. So that's 10 million cells, and it's already done 800 iterations. So this is going to take, well, I want it to do 10,000 iterations, so I know it's going to take about 2 minutes to run. So yeah, if you want, you can go back up and look at some of the input variables to check everything's been specified properly. You can look through the meshing details. So here it tells us that I've got, well, 10 levels, first of all, 10 octree levels. The number of octree cells is 10.5 million. The number of leaf cells is just over 9 million. The number of points is almost 10 million. The number of octree points is 23 million. So that's the number of octree cells required to capture all of the points, which is a bit confusing. But here it tells me the minimum cell size is about 0.5 meter, and the largest octree, you know, the domain is 500 meters. So with 10 levels, it brings it down to 0.5 meter. So that's the surface mesh refinement is about 0.5 meter. And that has finished. So when it's finished, I'm not saving the whole solution because that's big and it takes a while to write. Um, but what it has done is taken just a fraction over 2 minutes, and it saved two slices and the convergence data. So I'm saving the octree, I'm saving the VTK slices, and I want to download them. So download them. So that's taking 2 minutes to run, and then I can download the solution and look at it. Because I've been through this a few times already. Copy those. I'm going to copy them into my post-processing directory. Copy them into there. For some reason it creates these additional files which I don't want. So yeah, now I've got my VTK files, I can actually look at them. So I've got this set up in PowerView as a state file, so I can literally load state. And then that will load in the data. So that's my actual solution. What we're looking at, velocity. It's interesting why that's red in the middle. I'm not sure where that is. I'll have to look at that. But that has basically from the solution, we calculate the speed, then pass only the speed array through to, and then use resample with dataset to interpolate that data onto data points. And then we plot the data and save it. So I'm going to save that on top of the existing CSV file. So more test.csv. So that file has just been saved. So it's just point data speed and point mask, whatever that is. So then I normally do run a short script just to get rid of the commas. That gives me that data. Then I can compare that with the test data, like so. So this shows the CFD data in purple overlaid onto the experimental data, which is in this sort of light blue turquoisey colour. So you can see that it is the trends, some of the trends are being captured in terms of these peaks and troughs, but the correlation is still not very good. The CFD is not capturing this large point here. It's roughly the right sort of order of magnitude. All of this has been normalized by the reference velocity. Then I've got some code that can do the Pearson correlation. So that's telling me that the correlation between those two sets of data is 0.4, which is not very good. So that's what I'm working on at the moment to try and improve that. But anyway, if we just go back to the actual result, the flow solution, get rid of the perspective view. You can see what I'm actually modeling is that level of detail. If I change that to distance field, or LCD. You can see the mesh compared with the actual geometry. In fact, I can overlay the geometry on that. So that's the geometry that we're looking at. And that's the sort of mesh resolution that I've got on it. So yeah, I've just been looking at this solver to see if I can get any decent results for this sort of pedestrian wind comfort test case. So that's a very quick demo of running an octree solver on GPU by Runpod.